Hey y'all, how's it going? And welcome to CodeBlaze. And today we are going to be looking at object pools in Unity. So object pool is a simple design pattern that you can use in specific places to really optimize your game and reduce the overall garbage collection overhead. So to get started, I'll explain what object pooling actually is. So I have created that diagram using my super paint skills. So let's assume we are creating a mobile game in which we have a player or a rocket ship that we can control, which shoots bullets in an upward direction. So assume this black box as the screen that is visible or what is rendered on the screen. And we have this bullets shooting here, and we have some trigger or a collider 2D outside the visible region. So what you would typically do is whenever the fire key is pressed, you would be instantiating some prefab, which would be a bullet. And to limit the number of bullets, you could do is whenever the bullet hits this trigger, you would destroy this. So by this way, you would be instantiating multiple bullets and then you would be destroying them here. So instantiation not will be here. So here you will be instantiating them. So I'll denote that with I, and here you will be destroying them. So this is okay if it's pretty simple use case and if you're instantiating a fairly low amount of stuff. But each of this instantiate and destroy calls are actually a little bit significantly heavy as they add an garbage collector overhead. So whenever this is destroyed and whenever they're instantiated, memory is allocated and reclaimed. So rather than instantiating and destroying them, what we can do is use an object pooler, and with that we'll say like we'll instantiate 10 or 20 bullets at the start of the game, and whenever the fire button is pressed, we'll move one. So we'll have this object pool here, which will have multiple bullets, let's say. So whenever the fire button is pressed, we'll take one bullet from the pool and change its transform position to be here. And whenever the bullet reaches our trigger collider, so we'll take the bullet here and basically return it back to the pool. So in an essence, the bullets will be traveling from here to here back and then go here as our gameplay logic dictates. So this is basically what object pooling is. So with this method, you will have a fixed set of 10 or 20 objects initialized once. You won't have any destroy calls or any instantiate calls after that. So there isn't going to be any garbage collection overhead, and you can really optimize stuff, especially in case of mobile platforms. So to see an example here, we'll jump back to Unity, and I have created a simple scene in which cubes will be initialized towards the left of the screen, and once they get towards the right of the screen, they will be reclaimed. There is a trigger here, and you can see these cubes are will continue going like this. And in the inspector, you can see there are actually only 5 cubes which are recycled again and again. So this is what my object pool is doing. It's recycling these cubes and updating their position and transform as in when the claim and reclaim actions happen. So let's get started with implementing this logic. So I have created a simple C# class here called my object pool. And the first thing that we need to decide is what internal data structure our pool will use. So we can either use a queue or a stack or any other data structure that could benefit in your case. And we'll basically be using, so in case of a queue, we would be using enqueue and dequeue operations. And if you're going with the stack, you would be using the push and pop operations to basically add and claim and reclaim items to the object pool. So here I'll be demonstrating the example by using a queue, and it's up to you whatever data structure you want. So I'll define a private member. So it would be private read only queue, and I'll have my object pool be of type game objects for now, but later on we will improve the API of our object pool, and I'll show you some other enhancements that you can do for your object pool. And this can be called pool, And since it's a read-only object, we'll need to initialize this in our constructor. And but before that, we can add some other utilities here, or we'll basically define the contract of our object pool. So one thing that we will need is a public int size. So this will basically return the current number of objects that are available in the pool. So that will basically be pool.count. So it can be useful in some cases to have this. Next, we'll have our public game object claim method. Okay, so I'll implement this afterwards. And finally, we'll have our public void reclaim method that will take a game object and add it back to the pool. So now I'll go ahead and implement this in a fast forward section. So we'll be back. So here we have a basic object pool implemented. So the way we construct our object pool is by passing it an enumerable of game objects. Now this could be a list or an array. So you will basically be initializing all your objects somewhere else and passing it to the pool, and the pool will then maintain them. And finally, the claim and reclaim methods are basically the dequeue and enqueue operation of the queue. Now we can improve the object pool to make it more reusable or easy to use by creating it like having a generic parameter here rather than just limiting it to game objects, so that we can create object pools of anything we want in strings, game objects, materials, mono behaviors. And the other thing we can do is improve the construction logic. So sometimes it may not be the easiest thing to create this array beforehand. So let's do that and go into a quick time lapse section again. So now we have created our object pool to be generic, so it can hold any type of objects we want. And I have also added one more constructor which takes in a capacity and a func. So func is nothing like we can pass in a function which takes in an int argument and returns a t object type. So this is our builder function that we will be able to pass when we are creating an object pool. So this way we don't need to create a list or an array of objects beforehand. We can just give a builder function to and tell the object pool how to create that each individual object. And the way it's implemented is by using a simple for loop. So it goes from I to capacity and enqueues an item using the builder function. Now there are few more improvements that we can add here. So basically adding an claim and on claim callback. But we'll first look at how this is being used in a working example and then justify the need of those callbacks. So back in my object pool example script, I have a simple mono behavior defined here, which basically instantiates our object pool using the builder constructor. We specify a capacity of 5 and pass in a builder delegate, which instantiates our game object, which I have as a serialized reference here. So it's basically a prefab. Then we change the name of the game object to indicate which object this is. So we basically use this index here to specify whether it's cube 0, cube 1, cube 2. And by default, we set our game object active as false. So this is generally what you would want. You don't want your objects that are in the pool to be active in the scene. So that way you can save a lot of performance. Next, we have an invoke repeating function. So this function basically spawns cubes at a 2-second interval and sets their transform. And we have an on trigger enter. So we have a trigger specified on this game object. So whenever our cubes touch this trigger, they will be reclaimed back to the pool. So one thing that we need to do here is that I kind of forgot. We need to make the game objects active when we claim them, and we need to set them back as false when we reclaim them. Cube dot set active false. Otherwise, we won't be actually seeing our objects here. So let's go to Unity and check whether this is working or not. So Let's save this. I didn't refresh here. Okay. So if you see my pool script, we have this prefab reference here, and as you can see, as I press start, 5 cubes were instantiated, and they are basically recycling, and that's visual indicative of our object pool working. So whenever they gray out, the active state is set to false, and you can pretty nicely see that we are only reusing 5 objects again and again, and having an it appears like an infinite source of cubes spawning and despawning. So with that, our object pool implementation is pretty much done, though we can add some few improvements to it. Like, for it would be better if that game object set active and true and false could happen automatically, because we could forget it while claiming. So to improve that, I'll add some on claim and on reclaim callbacks. So as you can see, I have added two actions, the on claim and on reclaim actions, as member variables to the object pool. Now, if you don't know the difference between an action and a func, you can Google it. But basically, an action is a callback method or a delegate which always returns void type. So with the generic parameters here, we basically specify the arguments that we can pass to this action. But in a func, the last generic argument specifies the return type of this delegate. So since we don't want our actions or these on claim and reclaim callback to return anything, we can use the action type here. So these two parameters have been added to both the constructors with the default value as null. So that makes it optional to specify the on claim and reclaim callbacks, since in all cases you won't require them. And in our claim and reclaim logic, we basically conditionally invoke these callbacks. So if they are defined, we invoke them with the object that has been dequeued. And if the on reclaim is defined, we invoke it with the object that is going to be added to the queue. So if we go back to our pool example, we can remove these lines here and add it to the constructor only. So we can say cube, and we'll pass in a delegate cube dot set active as true. So whenever an object will be claimed from our pool, the game object state will automatically be set to true. And similarly, we can pass a reclaim callback here. So that would be cube dot this delegate cube dot set active as false. So this way we can have some general activation and deactivation logic right here when the object pool is constructed. So if we are using the object pool in multiple places, we can be rest assured this set active and set deactive thing is something, even if we miss, will be handled by the object pool. So if we look back in Unity, everything should work as it is, as it was working before. It's just our API is now more usable. So let's see that. Yeah, as you can see, we still have our cube spawning. By default, their state is false, and they automatically update their active state. And that's it for this tutorial. So one last thing is that this object pool is actually available as part of the Codeblaze Unity library. And there is another type of object pool available, the lazy object pool, which initializes the items as and when required. And there are other exciting stuff also in the library, and I'm also working on a GitHub pages documentation for it. So feel free to check that out. It's open source, and if it helps you in any of your projects, do share your experience down below in the comments or on GitHub. And that's it for this video. Do subscribe for upcoming videos, and if you have any other suggestions, or if you want to see some other tutorials, leave them down below in the comments. Share it with your friends. It really helps me out. And thanks for watching. Bye.